taught on Friday, over section 2-7, I taught you up, down, left, right, stretch, compress concept, correct? I talked about finding your vertex. I talked about finding your axis of symmetry. And every time we found all that information, afterwards I had you graph things by hand, correct? Now, I did not make you graph them for homework. I made you simply find them for homework, and now tonight what we're going to do is we're going to apply that information and actually graph it. What I need you to understand is that whenever I graph a V, just like whenever I hold my hands up, that my elbows, my Y values of those points will be exactly the same. If I have my hands up in the air, my Y values of my hands will be exactly the same. And the distance from the axis of symmetry will be exactly the same for my X coordinates. Do we agree with that? Okay? Now we're going to take that same application, or that same concept, we're going to apply it graphically. The vertex is known as the point HK, correct? In addition to that, what we learned yesterday or on Friday was going to be that A is equal to my slope. What is slope? Rise or run. So if I'm giving you an A value that's a whole number, what should I turn my whole number into immediately? A fraction by simply putting it over 1. Do we understand that? Okay? Now, we needed to find other points. Yesterday we found other points using the slope, which is the rise or the run. If it was a mountain, what did we do with our rise? We actually go up, or what did we do go down? Which one? We went down from our vertex, and then we went left and right. If we're a valley, what did we do? We went up, and then we went left and right. Do we understand that? Now, what I'm giving you today is I'm giving you a formula. This formula is basically saying that I'm going to take my X value, which is my H, from my vertex, and I'm going to run both left and right from it. Adding, which would be plus to the right. Subtracting, which would be to the left of my run. Do you understand that? And then what I'm doing every time to my K value is I'm simply adding my rise. Okay? Now, if I'm a mountain, I'm not going to be adding my rise, am I? What I'm going to be doing is subtracting my rise. Do we get that? Because I have a highest point, the peak of the mountain. So I need to go down from there. So that's why I'm subtracting. If I have a valley, what that means is I'm coming from the lowest point, and I need to add the Y value to that to raise that Y value up. Do we understand that? Yes or no? Everybody got that down? Okay, now I try my absolute darndest every time to give you guys a step-by-step procedure so that whenever you go home and you are lost because you do not remember a single thing that I said in class, that you are able to read what I told you to do and be able to get the answers, okay? So step one, the procedure that you're going to follow is you're going to take the jump that's inside the absolute value, set it equal to 0. That's step one. Step two means you're then going to solve this for X. This is your H value. I cannot tell you that enough. This is your H value, okay? Now, how do I find my vertex? Well, my vertex is the point HK. If I know what H is, how do I find K? Where's K at in that lovely equation? Where's K at in the lovely equation? The jump after the absolute value that you've added or subtracted to it, correct? It's the up and the down, the vertical shift. After we find our vertex, which is our H and K, what we're now going to do is we're going to address the concept of finding our A value. Our A value does a lot of information for us. It gives us the up and down. It gives us the mountain or the valley, the max or the min concept, and it also tells me if I'm stretched or compressed. Do we understand that? Now, what we're going to have two A values. We're going to have an A value, which is the slope on the outside of the absolute value sign, and then we're going to have an A value on the inside of my lovely little absolute value. Do we understand that? What is A also known as? Slope, right? A is also known as slope. So whenever I'm saying find your A value, I'm saying find the slope on the outside and find the slope on the inside of your absolute value. You with me? After you find your two A values, I need you to multiply them together without the negative. Now that negative is a little bit confusing. Let's say you have a negative on the inside of your absolute value. Okay? Let's say you have a negative on the inside of your absolute value. What is the absolute value of negative 5? 5. So can it be negative whenever you pull it on the outside? Can you have a negative number when you pull it outside of an absolute value? No, the outcome always has to be positive. Do you understand that? So whenever I say to multiply them together, ignoring the negative, I'm talking about ignoring the negative on the inside. Okay, we'll do an example of that. Graph the vertex and then find the other points to be by using h plus or minus the run, comma k plus the rise. You with me? So let's go ahead and apply this logic. So step 1, what should I do? Step 1, what's it say to do? Take 3x minus 6 and set it equal to 0. So then, what's step 2 say to do? Solve this for x. So what do I do? Add 6 to both sides. So I'm going to have 3x is equal to 6. Divide both sides by 3. And x is equal to 2. Now what is this? This is your h value. So if this is my h value, what do I need to find? I need to find my k value. Well, where is k at? K is going to be the stuff on the outside of the absolute value, so k is going to be 1. Do we all understand that? Yes or no? So now what is my vertex? So my vertex is going to be the point 2, 1. Do we all see that, yay or nay? Okay, well now what we need to do is we need to find our a values, correct? So tell me, look at our a values. What is my outside a value? If I'm on my outside of my a value, I just talked about this previously, right? There's not anything there, so if there's nothing there, what's understood to be there? 1 is understood to be there. So we need to make sure that the 1 is there. You need to put it there, physically put it there. So my outside a value gives me a positive 1. That positive 1 is responsible for telling me if it's a mountain or a valley. So what is this? This is a mountain or a valley. It is a valley, which means since it is a valley, what do I know? Do I have a max or a min? What do I have? I have a minimum value. Okay? Now what is my inside a value? Whenever I talk a value, your brain should be thinking slopes. The slope of the inside is going to be 3. But I need to take the absolute value of 3. Okay, so please don't forget to do that. So what is the absolute value of 3? 3. Now what does it say to do after you find both of the a values? To multiply them together. So my total a value is going to be 1 times 3, which gives you 3. Now, since that's a whole number, what do I do with it? I'm sorry? Okay. Put it over 1. Good. So to put it over 1, we want to make it a fraction, right? Because this is my slope, which is going to be rise over run. But since I have a minimum, what do I do? Do I go up or do I go down? I am going to go up 3 units, and then from there, I'm going to do what with my run? Go left and right. So I'm going to come over here to my lovely little graph, and I'm going to graph this. And what point do I start off graphing? I'm going to graph point 2, 1. There's 2, there's the point 1. Is that a min or a max? It's going to be a min. So from there, I need to go up 3 units, 1, 2, 3, into the right 1. Up 3 units into the left 1. Do we see the V? Yes or no? Okay, so I'm going to connect those. Okay. There's my 2 lovely points. Now, Can somebody please tell me the ordered pairs of those points? What is this ordered pair to the right? That's going to be the point 3, 4. What is the ordered pair on the left?
1.
That's going to be the point 1, 4. Now, this is great whenever you can see them because they're all whole numbers, correct? Okay, now I want you to prove to me algebraically how you come up with 1, 4, and 3, 4. Notice, whenever we graph them, that the y values are what? The same. It's supposed to be because what do we know the v to be? That little s word? Symmetrical, right? Okay? So what we're going to do is we're going to show this algebraically that this is the correct way to do this. So how do I go about doing this? My first point and my second point. Where did I start from on both of these? How did I get them? I started from which point? My initial point, which was my vertex. Well, my vertex is the point 2, 1. Notice how I'm leaving lots of space. 2, 1. How did I get my first point? I went up. What does up mean? Add or subtract? Add. Up means do I add it to my x value or my y value? I'd add it to my y value. So I added on both of them, didn't I? To my y values. Correct? Now, when I'm running to the right, am I adding or subtracting? I'm adding. Okay? When I'm running to the left, what am I doing? I am subtracting. Do you see what changed there? Now, what am I adding? What am I adding? I'm going to add my run. Well, what's my run? 1. What am I adding to my y value? My rise, which is the 3. Do we see that? So now what is 2 plus 1? 3. What is 1 plus 3?
4.
4. Come down here. What's 2 minus 1?
1.
And what's 1 plus 3?
4.
Do those points look familiar?
No.
Do you see how we came up with them? Does that make sense? Okay. Now, you only have to do this check if you have a fraction. Let's say, for example, my vertex was the point 1/2, 2/3. And I have a mountain. And my slope is going to be, let's say, 2. So how do I make that? What's the 2 turn into? 2 over 1. So to get my points, I'm going to have to take my vertex, which is 1/2, comma 2/3, 1/2, comma 2/3, right? If I'm a mountain, am I going up or am I going down? I'm going down. So am I going to add or subtract if I'm going down? What am I subtracting from, my x or my y? I'm going to subtract from my y both times, aren't I? And what am I subtracting from? What number am I subtracting from my y's? Think about this. This is rise. This is run. What am I subtracting? I'm subtracting my rise, which is 2, because I'm going to go down because this has a maximum. And I'm going to run left and right 1. Do you understand that? So I'm subtracting 2 both times. Now my x's, which is the 1/2, which is my h, what am I going to do back? I'm going to add my run, which is 1, and I'm going to subtract my run, which is 1. Did we get that? Now, if I have $1.50, that means I have $1.50, 1.5, correct? If I have $2, if I have 2/3 and I subtract 2 off of that, what do I have to do? That's going to give me, put this over 1, I need a common denominator between 3 and 1, that gives me a 3, so 3 times 2 gives me 6. So that gives me 6 over 3. Can you use your calculator for that? Yes. Okay. So what is 6 minus 2 minus 6 gives me? -4/3. Now what's 1.5? Do the C roll.
3.
2 times 1 is 2 plus 1 is 3 over 2 comma negative 4/3. Would you have gotten that graphically?
No.
No, you would not have. Okay? Come down here. I owe $1. I have 50 cents. So how much do I have? I owe $1. I have 50 cents.
You have compared 50%.
Negative 50 cents, which is negative 1/2, right? It's right here. What's 2 minus 6? Negative 4. What's 3 over 3? It's going to be the 3. These 2 points is what you need, along with this vertex. Would anybody get that graphically? No, which is why I'm showing you how to do this by hand, too. Do we get that? If my vertex are all whole numbers, do I need to show this by hand? No, but if I have a vertex with fraction, do I need to show this by hand? Yes, I need to show it by hand. Are we good? Okay, let's get down to the last problem. On the back. The best you can. Eyeball. That's why I'm giving you the points. Okay, step 1. Take the jump that's inside, which is the 3x plus 6, set it equal to 0. Now what do I do? Subtract the 6, so 3x is equal to negative 6. Divide by 3 to give me x is equal to negative 2. What is this actually?
Have your attention, please, for one final announcement. Our leadership council would like to.
Okay, this is going to be h. So if this is h, how do I find k? This is going to be k. So now what is my vertex? Negative 2, negative 4. So from here, now I need to find my a values. What's my outside a value? Now that negative tells me what? Is it a mountain or a valley? This is going to be a mountain, which means do I have a max or a min? I have a max. Excellent. What's my inside a value? What is the absolute value of 3? 3. Now what do I do with those 2 a values? I'm going to take negative 2 times 3 to give you negative 6. Multiply them together, correct? Now, is that a fraction? What's the absolute value of 3? Outside a value, inside a value. Okay? Now, how do I make that into a fraction? Put it over 1. Now, since I have a max, what am I going to do with my 6? Am I going to go up or down? I'm going to go down 6, and then I'm going to go left and right 1. And where am I going to start that from? I'm going to start that at negative 2, negative 4, which puts me there. I'm going to go down 6 units and to the right 1, down 6 units to the left 1. There's your graph. Do we see that? That's what I expect you to do tonight for homework. And I want this point over here, which is going to be negative 1, negative 10, and negative 3, negative 10. If this is a fraction, it meaning the vertex, then I need you to come up with those 2 points algebraically. If you did not get a fraction for your vertex, then you could just do it graphically. Do we understand that?
Like you don't have a K.
If there's no k value, what's it understood to be, like in this example? What's k here? Yep. Okay. Please put all the calculators away around you. I would greatly appreciate it.